focal length?
2.9.
2.9? Does that sound about right to you guys? Did anyone get 3?
I got
Okay, how many people got 2.9? Okay, well, it looks about half and half, so I'm gonna go with 3 because 3 is easier, but 2.9 is fine. What'd you guys get for the image distance?
4.7.
Say that again? 4.3, how many people got like 4.3 or thereabouts? What other answers did you guys get?
4.7.
What'd you get, Tyler?
4.7.
4.7, how many people got like 4.7 around there? How many people got, how about 4.6? How many people got 4.5? How many people got 4.4? How many 4.8? Okay, so I'm just gonna go with 4.7. Hope you guys don't mind. Right or wrong, I don't know what it is. And who measured the image height? What did you guys get for that?
0.8 centimeters.
0.9.
0.9 meters?
0.8.
0.9 centimeters? 0.8 centimeters? How many people got 0.8 centimeters? How many people got 0.9 centimeters? Half centimeter? Oh, we'll go with 0.8 centimeters then. Okay, I'm just kind of getting the average. Okay, so you guys, by doing ray drawings, you identified where the image would be. If you had a mirror of that curvature and an object 7 centimeters away from the mirror, then the image would be around 4.7 centimeters away from the mirror. You located the image. You located where the bright, image shining on the wall would be, all right? But there's a way to do this mathematically, and it's by using something called the Lensmaker's equation. There's actually a mathematical relationship between the object distance, the image distance, and the focal length. And that mathematical relationship is as follows. Lensmaker's equation. 1 over d sub O plus 1 over d sub I equals 1 over f. That's the Lensmaker's equation. So let's go ahead and predict what d sub I should be mathematically. Your d sub O was 7 centimeters. Your d sub I we don't know. Your focal length, well, some of you got 3 and some of you got 2.9. If you got 2.9, you should put 2.9 there. If you got 3, you should put 3 there. So I'm just going to trust that you guys are good at algebra, or good at algebra, I guess, or arithmetic. We're going to subtract 1/7 from both sides, and then take both sides to the -1 power. So you get an image distance of 3 to the -1 minus 7 minus 5.25. Wow. So the Lensmaker's equation predicts an image distance of 5.25. Did anybody in here get close to 5.25? Like more than 5?
Nope.
You did, Simran?
I got 5.25.
Good. For the calculator?
Yeah.
But I mean measured. Did anyone do a ray drawing that resulted in 5.25? Okay, well that's fine.
4.8.
So that's what the Lensmaker's equation does for us. I must teach you another equation now. And
mine got
you
squared
just walked in
now,
as
it's
Mr.
locked
Armio. That's why you see my button.
I'm sorry to interrupt, but they're gonna be doing some coring out here. They're doing some drilling for the new facilities gonna be eventually built out here. So there may be a little bit of noise. I just wanted to give you a heads up.
Thank you.
Okay.
Yeah. I mean, if it's too much, I'll find the breaker switch and just turn it off.
Okay. Thank you, sir.
Okay. Yeah, and I'll have names and numbers for you at the end of our
That's perfect. Thank you.
Alrighty, there's another equation you must know, and that's the magnification equation. And let me write that right here. And the magnification says this. The magnification, which we tend to call M, and the magnification is the ratio of the image height over the object height. If the image height is the same as the object height, then your magnification is 1, and you've got a plane, that's, for example, a plane mirror has a magnification of 1. If your image height is bigger than your object height, you have an image that's bigger than the object. You've magnified the object. Your magnification would be greater than 1, like 2 or 5. If the image height is less than the object height, then you shrunk the object down. The image is smaller. Well, that ratio, h sub I over h sub O, ends up equaling d sub I over d sub O. That's the relationship between magnification, which is image height over object height, and the image and object distances. The ratio is equal to each other, yes?
Are we gonna get something to identify if it's upside down or not?
Yeah, that's gonna happen right now. Yeah, and because, just 1 second, you know what? I messed up this equation now that you mention it. The equation is not just d sub I over d sub O, it's negative d sub I over d sub O. Negative d sub I over d sub O. So sorry about that. I'm not even gonna edit it out, I'll just leave that mistake in there.
Oh.
Yeah, so Tim, actually, it was really lucky that you asked that, because how do I know about magnification? The negative sign tells me about it. So let's look at this problem. The magnification, the predicted magnification, should be d sub I, which we found to be 5.25, but it's negative 5.25, over the object distance 7. That's my magnification, and that should equal h sub I over h sub O, which is 1 centimeter, correct? And so I get 5.25 divided by 7 times 1, I get negative 0.75 centimeters equals h sub I. So the predicted image height is 0.75, and so you guys getting 0.8, we're right on the money pretty much. But I want now to ask you, what is the meaning of that negative? Why do they have that negative sign there? Yes, Chris?
Can be inverted.
Yeah, because the image is inverted. Just like what you see on my little light bulb demo, the actual light bulb is upside down. The actual light bulb inside that black box is upside down so that the image is right side up. So that's an inverted image. However the object is oriented, if the image is upside down relative to the object, that's an inverted image. So are you guys okay with this? The lens maker's equation to predict where the image distance is, and the magnification equation to predict what the image height is going to be. And that's what you guys are going to do on another example momentarily. Let me just end this particular problem by asking this. This image, there's 3 things you can say about this image. I won't ask you, I'll just say it. Number 1, it is real. Because real light rays are coming together to hit it. Number 2, is that image inverted or upright?
Inverted.
It's inverted because it's upside down and the object is right side up. So this is an inverted image. And then finally, number 3, is the image reduced in size or enlarged? Reduced. Yeah, it's reduced in size because the magnification is less than 1. Okay. So now, please look at your talent notes for the chapter 25. So go back to the first page. If you answer number 5, a concave spherical mirror is called a converging mirror, because when parallel rays of light hit the mirror, they reflect off and all pass through the focus. So write that in. And then look at number 6. The object distance is the distance between the object and the vertex. If you were to say the object and the mirror, you'd be right as well. But specifically, it's the vertex of the mirror. But just conceptually, yeah, between the object and the mirror. The image distance is the distance between the image and the focal length is the distance between the and the Good, write that in, please. Okay. Number 7. the ratio of the image height to the object height is called the,
Magnification.
good, magnification, please write that in. Number 8, the lens maker's equation is, someone tell me, what's the lens maker's equation?
1 over d O plus 1 over di plus equals 1 over f.
1 over AR is equal to 1 over.
Yeah, there it is, 1 over d sub O plus 1 over d sub I plus 1 over f. Please write that in. And then the magnification equation is what?
M equals h sub I over h sub O.
Yeah, please write that in. You are now ready to do problem number 1. Please read problem number 1 and then answer the questions using the lens maker's equation and magnification equation. Good luck.